It is 1981, somewhere in Tokyo. A driver sits inside a Honda Accord as rain slides across the windshield under the glow of neon streetlights. The city moves in fragmented reflections, signs blurring into a language of light and motion. Inside the car, something unusual is happening. A small green screen is alive on the dashboard, and on that screen, a single glowing dot moves. Not randomly, not approximately, but in real time, tracing the exact path of the car as it turns through the city streets. There are no satellites above, no digital maps in the cloud, no GPS. Nothing we associate with modern navigation. And yet the car knows where it is. Before we go deeper into how this was even possible, if you're drawn to these kinds of forgotten engineering systems that quietly shape the modern world, make sure to subscribe to The Lost Design and join us as we uncover the technologies that almost defined our future. Because some of the most important inventions were not the ones that succeeded, but the ones that briefly showed us a different path. This was not science fiction. This was Honda's Electro Gyrocator, and it should not have been possible in 1981. To truly understand the audacity of this machine, we have to look at the world before digital maps defined our reality. Today, we navigate with absolute certainty, guided by an invisible celestial grid. In the early 1980s, driving was entirely physical, mental, and uncertain. If you missed a turn on an unfamiliar highway, you were at the mercy of your own memory, or the accuracy of a paper map that was likely already outdated. Getting lost was not an occasional inconvenience. It was a normal, expected part of travel. The concept of an in-car navigation system was a fantasy, restricted to the realm of conceptual design studies. The technology required to track a moving vehicle in real time simply did not exist. Satellites were the exclusive domain of the military, and computer processors small enough and powerful enough to calculate geographic coordinates on the move were still years away. The automotive industry was firmly rooted in mechanical engineering. To suggest that a car could somehow perceive its own position on Earth without external assistance was treated as madness. The world was analog, and the tools we used to navigate it were static. This was the monumental challenge facing automotive engineers. How do you track a vehicle's precise position across hundreds of miles without a single satellite to guide you? Without external reference points, the problem seemed insurmountable. If you cannot look down from space, you have to look inward. You have to rely entirely on inertial navigation, calculating your current position based solely on a previously known starting point, the direction you have traveled, and the speed at which you have moved. In theory, the mathematics are straightforward. If you know where you started, and you track every turn and every feet of distance perfectly, you can calculate where you are. But in reality, the physical world is chaotic. Tires slip on wet pavement, roads curve imperceptibly, and even the slightest mathematical error compounds over time. A tiny fraction of a degree of error at the start of a journey translates into being miles off course, just an hour later. To solve this, engineers needed a sensor that could detect changes in direction with microscopic precision, long before microchips and digital sensors were capable of the task. The answer came from an unexpected place, born from a philosophy that refused to wait for the future to arrive. In 1981, Honda introduced the world to the Electro Gyrocator. It was the world's first commercially available in-car navigation system, and it was unlike anything the automotive industry had ever seen. Developed as an expensive option for the Honda Accord and Honda Vigor, it looked like a cross between a television set and a piece of military laboratory equipment integrated into the center console. Honda did not attempt to build this system because it was easy or profitable. They did it because they wanted to prove that the limitations of the analog world could be overcome through sheer engineering ingenuity. The Electro Gyrocator was a statement. It was proof that a vehicle could possess an internal sense of direction. It represented a primitive digital future, a bridge between two eras that shouldn't have been able to exist yet. It was an incredibly complex solution to a problem the rest of the world hadn't even begun to tackle. The true magic of the system lay deep inside its mechanical housing, where engineers managed to create a flawless digital illusion using purely analog principles. At the heart of the Electro Gyrocator was a gas-rate gyroscope. Unlike traditional mechanical gyroscopes that rely on a rapidly spinning wheel, this system used a continuous stream of helium gas directed at two heated wires. When the car drove in a straight line, the gas hit both wires equally, keeping their temperature identical. But the moment the car turned, the inertia of the gas stream caused it to deflect, hitting one wire more than the other. This temperature difference altered the electrical resistance, allowing the system to calculate the exact angle of the turn. To measure distance, a sensor was attached to the transmission, counting the rotations of the gears. A custom-designed 16-bit computer took these two inputs, the change in direction from the gas sensor and the distance from the transmission, and translated them into movement on a cathode ray tube display. But there was a catch. The system could calculate the car's movement, but it had no digital maps to display. The memory required to store a map of Japan on a microchip in 1981 would have required a computer the size of the car itself. To bypass this impossible limitation, Honda's engineers came up with a brilliantly simple, yet incredibly complex solution. They used physical map overlays. The system came with a leather binder filled with transparent plastic sheets, each printed with a section of the road network. Before starting a journey, the driver had to locate the correct transparent map for their area, physically slide it into a slot in front of the glowing screen, and use a set of manual controls to align a glowing cursor with their current starting position on the paper map. As the car drove, the internal computer did not move a digital map. It moved the glowing dot behind the static plastic sheet. It was a literal mechanical illusion of digital mapping, a beautifully complex dance between physical ink and glowing electrons. For the driver, experiencing the Electro Gyrocator for the first time must have felt like stepping into an alternate timeline. Turning the ignition key brought the small monochrome green screen to life. As you drove away from your driveway, the glowing dot began to crawl across the plastic map overlay, tracing your turn onto the main street, holding its position perfectly as you accelerated down the avenue. If you transitioned from one map sheet to another, you had to pull over, pull out the plastic overlay, slide the next one in, and recenter the dot. It was a user experience that required patience, precision, and a willingness to cooperate with the machine. Early users spoke of a strange sensation, a mix of awe and mild anxiety, as they watched a mechanical system try to keep up with the real world. The system was highly sensitive to environmental factors. Driving up a steep hill, experiencing tire spin on ice, or even parking near a strong magnetic field could throw the calculations off, requiring the driver to manually adjust the cursor back to reality. It was a human-centered technology that demanded human partnership. Despite the sheer brilliance of its design, the Electro Gyrocator was destined to remain a rare artifact of a transitionary era. The system was astronomically expensive, costing nearly a quarter of the price of the entire car it was installed in. It was heavy, complex, and required a level of interaction that the average commuter found daunting. But its ultimate demise did not come from its own limitations. It came from the rapid, relentless march of external technology. Within a few years of its release, the United States military began opening up its global positioning system for commercial applications, and the first true digital map databases began to emerge on compact discs. The moment a car could look up at the sky and receive its exact coordinates from space, the need for gas-filled gyroscopes and plastic map overlays vanished overnight. The Electro Gyrocator was rendered obsolete not because it failed, but because the world changed around it, rendering its incredible internal architecture unnecessary. The Honda Electro Gyrocator stands as a profound monument to a brief, beautiful moment in engineering history. It represents a parallel technological path that was explored, perfected, and then completely abandoned as the satellite age arrived. It did not lead directly to the navigation systems we use today, but it proved that the desire to know where we are is powerful enough to bend the limitations of technology to its will. It forces us to appreciate the invisible systems that guide our modern lives by showing us just how difficult it was to simulate that reality before it existed. The Electro Gyrocator was not just an old car accessory, it was an act of pure imagination, a reminder of a time when engineers looked at an analog world, refused to accept its boundaries, and built a digital future out of glass, gas, and paper.